state your name and so that we know on the recording who it is asking the question. And then we'll go through that. But as I said, there will be plenty of time for questioning. Just a little overview. I'm going to go through a little Milltown restoration history. Then Matt Daniels and Amy Sacry will go over the restoration monitoring that has occurred over the last 15 years. We just finished, or they just finished the monitoring in 2025. So they'll talk about that data. Brian with Fish, Wildlife, and Parks is going to give us a parks update. And then we did invite MDT to come and give an update on the bridge. They couldn't make it, but they did provide some information so we can get a little schedule update on what's going on with the Blackfoot bridges and issues. So as far as the Milltown Dam remedy restoration, redevelopment, and participants, in the past I've tried to list names, but I've always left somebody off. So we decided at the program level to just say that it's too many to list because everybody was involved in this project, from the governor's office and the EPA top offices all the way down, to the locals, the landowners here, the public, the NGOs. So everybody needs a pat on the back, or should get a pat on the back for this project. I do have to recognize, though, EPA and Russ Forbes and Diana Hammer, they were key to pulling this off. Without them leading this project, we wouldn't be. So back in the day, if you remember, 1908, we had the flood on record. The Milltown Dam or the Milltown Reservoir, that was a reservoir filled up with sediments, and it became a run-of-the-river dam. And those sediments all came down from the mining operations in Butte and Anaconda that were laden with contaminated sediments. This is what the reservoir looked like in 2006 before work began, and ARCO and Envirocon started lowering the elevation. The one thing that I always found interesting is right there at that point, right above the G, there was about 25 feet of sediments right there when they did the final excavation. Down around 25 feet. And on this picture, you have the Blackfoot River on the left and the Blackfoot River on the right. So when the EPA decided to make the decision to pull the dam, which had also a lot of input from the local government and the local people here to push to get the dam removed, they decided to remove the area between the dam and what was called Duck Bridge at the time. And that's that line, the red line right there above the Roman numeral 2. That was what we called it. With from the restoration sites, because that's what we're going to talk about, the restoration here. We extended the quite a bit. The CFR project area, but CFR 3, we felt we had to go up and do work further up there in order to tie into the new elevations that were going to be created by the removal of those 2 million cubic yards and the dam. In order to tie that in and keep the gradient at the correct level, we went upstream up into that hole. That the river had been there since 1937. And the river was. The main goals of the restoration plan, and I need to will say that the report between the state of Vermont and the other trustees, the U.S. Fish and Wildlife. The main goal was to restore the Clark Fork and Blackfoot rivers near the Milltown Dam to be naturally functioning. We did want to maintain water quality. to maintain, actually, when we first started this project, I'm going off on tangents to just that. But when we first started this project, we had improved water quality. But there's 6.6 million cubic year, 6.6 million cubic yards of contaminated sediment at the site. EPA was removing 2. We weren't planning on removing much, and so improving water quality wasn't really something we had control over. So we did change that to maintain water quality. We wanted a channel that was appropriate for the valley setting that would transport sediments and be connected to the floodplain. We wanted to provide fish and wildlife habitat. We wanted to provide wetlands that were functional and a riparian community with diverse plants. Provide visually aesthetic qualities consistent with the natural setting, and provide safe recreation opportunities that were consistent with these goals. Some of the constraints that we had at the site, and this is important to always remember these. As I said earlier, there was 6.6 million cubic yards of contaminated sediments that was located, or that can be located behind the dam over the course of the year. Only about 2 of those being removed. There's an interstate here. We weren't moving the interstate, and that had has a large amount of contamination beneath that. There are 4 bridges at the site. We had limited pre-dam information when we started out on the design process. We moved into the negotiations with ARCO and Envirocon to integrate the restoration. We had very limited amount of data. We had the information from the remedial investigation. So that was difficult. There's limited site access. There's only 3 ways onto the site. And as I noted at the beginning, without EPA and DEQ leading this project, we would be here, and remediation was the driving force behind this project. The facts about restoration. We did move over 2 million cubic yards of material to construct the floodplain. We also moved about 400,000 cubic yards of contaminated material out of the floodplain. Worked on 17,000 feet of channel. We worked on over 500 acres of floodplain. Planted over 100,000 plants. And with that, we had no reportable injuries. And I'm happy to say that. And I'm glad Brian's here. Brian was the safety guy for Envirocon. He did keep track of all of us. That was very good. This is a map I'm told is difficult to look at. But it is the as-built map of what he built in 2011. This is what it looks like. If you go to the top half, and I know from a remote standpoint you can't see it, but above this little graph on the bottom, if you go to the right side, that's where we started channel work and stream bank stabilization. We left the channel in the same location that it was. And then when you get down to where you see a bunch of green and a bunch of blue, that's where we started to excavate and move the floodplain and regrade the floodplain, lower the floodplain so that it would tie in with the elevation of the new dam site. Then on the bottom half of the slide where you see the dark blue, the light blue, the green, and the yellow, those are different elevations of how we regraded and rebuilt the floodplain. The lower part of that floodplain is what was rebuilt by remediation as part of the negotiated settlement. ARCO and Envirocon were to build a, we called it the grading plan, but build the floodplain to the design that we had provided them. And so that was part of the negotiation. They did that, and we built the channel and did the revegetation. Some of the things that came up as I moved through the project was some of the information that became available. All of the stumps that were exposed during the work of the sediment removal, the contaminated material removal, we didn't know that we were going to run in and see all of those things. The contractors, in this case here at Envirocon, did a very good job of actually excavating around and leaving a lot of that material. In some places where this material was exposed and these stumps were exposed, we got a lot of self generating plants. Willows and cattails came up that have been buried for over 100 years. This picture also shows some of the other integration that we did. If you look in the background, you have the one haul truck that's going up that slope. That's the old tunnel pond area. If you go out there now, that's actually the slope that you see out there. And this was an opportunity that we worked on with the Clark Fork Coalition, because the main channel of the Clark Fork was going to be armored out of place. There was a lot of contamination in the channel. The Clark Fork Coalition came forward with a grant to the Natural Resource Damage Program, or a grant proposal, to take those sediments out while the work was going on. It was not something that we worked out in the negotiations, but with that grant, we were able to deal with Envirocon to come and take that material out of the channel of the Clark Fork and actually put it in the tunnel pond. That's what's going on here. So one of the things that always happened during this project, it always seemed to come up with some issues or I call them an issue. They're not going to call them great big problems, but we always work through them. There was always a very good set of eyes on the project from all perspectives, from EPAs, ARCO and Envirocons and the states, and making things work out and make sure we always got to the end and seem to be an end result. And this is one of those things where we got a whole bunch more material out of the floodplain, got a larger floodplain, and the benefit for everyone. So moving on. So tonight you're going to hear Matt Daniels and Amy Sacry talk about the monitoring that has been done. We did develop a monitoring plan for the restoration for the short-term goals. We have those, and that's what they're going to talk about. We also have some long-term goals greater than 15 years. To date, we have been out and done 5 different monitoring sessions. We monitored in 2010, 2013, 2015, 2020, and again in 2025. That does complete our monitoring that we had in our monitoring plan. And today we will talk to you about the results of that. And then at the end, we'll talk about where we're going to go. This last picture here is, I always had that picture on the left up there. Matt Sappho gave them to me. That was a picture that we talked about is, this is what we might have as a reference. What we're looking for in the future. And the picture on the right is from 2024, which I thought was appropriate. The site is getting there. Now I'll turn it over to Matt to talk about the Geum problem.
Like this.
Advances the slides here. Just a second. I'm not sure where your presentation went. Yeah, it's separate. That's just. All right. Am I still sharing, Aaron?
No, you are not.
Good to go? Yep, you gotta use that mic.
All right. Well, it's great to see all of these familiar faces here tonight. My name is Matt Daniels. I'm a restoration engineer with SWCA Environmental Consultants. You may remember River Design Group, which was the company that is now a part of SWCA. And I'm going to be providing a high-level overview of the 15-year monitoring that we've done on the channel and the overall geomorphic processes that are happening at Milltown. And I think to just kind of build upon what Doug had said about this project, it really has been a unique opportunity to work on a project where there's so much continuity between the project team, and Doug gave a lot of kudos to a lot of the federal agencies, but I wanted to also acknowledge the leadership from our Montana state agencies, in particular NRDP and Fish, Wildlife and Parks. And it's so unique to have the same people here that were involved at the start of the project 20 years ago. And I really do think that having that continuity is one of the keys to the success of this project.
No idea, Matt. Try it now.
Just
Try it now.
There we go. Okay. So Doug mentioned the project goals, and they're very broad, they're very general. But one of the kind of reoccurring themes that you heard in those goals is a naturally functioning river, a river that's connected to the floodplain, a river that has natural characteristics. And so that was really a challenge that we were given as the practitioners out there who had to come up with a design for this project. And before I dive into the monitoring, I'd like to give a little bit of background on the approach for the design on this project. And 20 years ago with river restoration, there really wasn't a lot of information out there. There wasn't a playbook. There wasn't a go-to manual for doing this kind of work. And so we really had to rely on data collection to measure characteristics from what we call reference reaches, or areas that had the characteristics of that naturally functioning river and floodplain. We knew that structures were going to be needed to hold this river together in the short term, but we didn't want it to be riprap. We didn't want it to look over-engineered. And so those materials that we used were wood, things that were native to the system, brush, gravel, and boulders. And the project approach really had a strong emphasis on long-term stability being provided by mature vegetation. So this was a huge challenge for our team to be able to come in and find a way to balance the short-term stability, but also accommodate the natural processes that are happening on this river, and also set the stage for an ecological function and the development of this floodplain. And I know this is really hard to read, but this is a exhibit from the design report. And what it shows here, I think Amy will talk about this in her presentation as well. It just shows all the diverse features that are found on the Clark Fork River floodplain. You know, you not only have a primary main channel, but you have a connected floodplain. You have side channels. You have terraces that bound where the channel can migrate, where the extent of the flood happens. You have disconnected oxbows that support different types of wetland habitats. And then you have higher terraces where you have more upland vegetation. And so all those different geomorphic features were things that we had to think about and apply to this landscape after all the remediation work happened. And then similarly, all those different geomorphic positions have different kinds of vegetation communities that can become established on those range of surfaces based on where the groundwater and the river water elevations are. So this is another exhibit from our design report that shows how we laid out all those different features on this site. So you can see different floodplains and terraces, side channels, wetlands, tributaries, other things. And so tying this in with the big picture geomorphology of objectives, we were really focused on floodplain connectivity, sediment transport continuity, and being able to establish dynamic equilibrium for this site. And when we got started, we had to come up with some performance criteria, some expectations for how this channel would function. And what we had come up with and what eventually went into our monitoring plan was we said, well, you know, the channel is going to end up being plus or minus 20% of the design dimensions. And that was based on what we had actually measured in our reference reaches. And so that kind of set the stage for our future monitoring and being able to evaluate how well this channel and this project is performing. So I'll shift gears. We'll start talking about monitoring, why we came here tonight. There are 3 monitoring reaches for geomorphology. It's a little different than some of the vegetation monitoring reaches. We have the Blackfoot River reach, and so that's a reach where there was no restoration done. It's a confined channel system, but there was a lot of work done to stabilize infrastructure, remove infrastructure that was at risk, and other things. And so there has been some ongoing geomorphic monitoring of how that reach has responded to damping. There's the Clark Fork River Restoration Reach, which encompasses the remedial project area and the area that Doug described. And so that's where most of the active channel and floodplain restoration work took place. And then for geomorphology, we included this upstream reach, what we call the Clark Fork River Tura Study Reach. And no restoration took place there, but we wanted to take a look at that reach and use it as kind of a control reach or an upstream response reach to see how that reach changed over time and compare that with how the restoration reach performed over time. So our monitoring timeline, we're at year 15. And so this timeline here lays out the kind of the project milestones as well as the different data sets that we had available to us for monitoring. The first 5 years, there was a heavy focus on data collection to monitor channel dimensions and channel metrics, a lot of the things that went into the design criteria for the channel. And it was very data intensive. It was very difficult to get out and do all these ground surveys. And after 5 years, when we got to the 10-year monitoring timeframe, the technology was starting to change. We had things like drones. We had LiDAR, which would become more accessible and more affordable for us to use. So at the 10-year monitoring timeframe, we kind of changed our approach using more of a remote sensing technique versus doing all of these intensive ground survey work. And in 2015, we did some additional LiDAR, and we also had a contractor go out and do topobathymetric LiDAR. So you may be familiar with that green LiDAR, and it basically penetrates through the water so that you can measure the bottom of the channel. We did have some skepticism that would work on this river. Green LiDAR is usually only effective in very, very clear water circumstances. And so because the Clark Fork River has a lot of natural background turbidity in it, the topobathymetric LiDAR turned out to be a bust and really something that we weren't able to utilize for our monitoring. So again, adaptive management led us to where we are today with the 15-year monitoring. What I'll talk about is our geomorphic change detection, channel turnover analysis, which is a fancy word for channel migration. We'll take a look at some cross sections cut from the LiDAR, look at the floodplain connectivity, and then field reconnaissance was a big part of the monitoring. So before I get into sharing some of our results, I also wanted to talk about the hydrology during this time frame. So we have gauges above and below the project area, so there's lots of great data available to evaluate. And we took a closer look at the data during this monitoring time frame, 2010 through 2024. And this hydrograph that you see on the right here is representative of the flows that occurred during this time frame. So solid blue line is the median flow. The darker blue line is kind of the 25th to 75th percentile. And then the lighter areas represent kind of the extremes for that time period. A couple things I want to point out about hydrology during this monitoring period is that we had big flows in 2 of these 15 years, 2011 and 2018. 2011 was more than a 25-year flood on the Clark Fork River, and it happened to coincide with the first year after the project was done. And I'll show some pictures of what that looked like. 2018 was a similar magnitude flood. I think on the Blackfoot, it was close to a 50-year flood. And the interesting thing between those 2 floods is that the impact that that flood had in 2011, there was dramatically more disturbance because the project was so new. But in 2018, after there was several years of vegetation establishment, the project was much more resilient and there wasn't as much damage at all, if any, and we didn't even do any maintenance after the 2018. Whereas in 2011, we did quite a bit of maintenance to go in and repair things after that flood. Another thing I want to point out about the hydrology, so our criteria for sizing the Clark Fork River was to size it based on bankful discharge. So what, in a nutshell, what that means is it's a flow that happens roughly 2 out of every 3 years. So it doesn't contain the big floods. It allows floodplain connection. And bankful flow during the monitoring period came pretty close to hitting that expectation, and bankful flow was exceeded for 11 of the 15 years during the monitoring. So I'll go through some of these photos from that 2011 flood. Gary Matson is here in the crowd. These are photos that he took from his plane back before we had drone capability. So we're really fortunate that he was out there frequently keeping an eye on it. So this is what the project looked like right after construction. So you can see all the features that we described: side channels, wetlands, oxbows, floodplain areas that are freshly regraded. But there's nothing to hold this floodplain in place other than the wood that we placed. It looks pretty darn vulnerable. And this is what peak flow looked like in 2011. This is looking to the west. Here's the former dam location. Here's the Blackfoot River coming in. And here's the Clark Fork River floodplain at close to peak flow. I don't know how Gary timed it, but great picture. And one of the things that I want to point out in this photo is that it really shows that how the design accommodated the change from the upstream Clark Fork River floodplain, which is really valley-wide inundation, the more confined the Clark Fork River channel. And it shows the function of those constructed terrace features to gradually make that transition to a change in stream time. And this picture is from just a little bit further upstream, and it shows that valley-wide floodplain connection at the upstream end of the project area. And then in the fall, this is what things look like. This was the time frame when we did go in and do maintenance. We had 2 avulsions that took place in the project area. One of them we fixed, one of them we didn't. We let it go. I think we worked on 1,500 feet of banks that got shredded by this flood. And And I think there was a lot of work that took place on the floodplain as well to deal with probably fences, and browse protectors and all kinds of, and there was weed mats probably scattered from here all the way down to Thompson Falls. So let's get into what we did for the 15-year monitoring effort in 2025. So geomorphic change detection. So this is the CFR project reach. What this is it's elevation difference mapping that's used to care between two data sets. We use the 2013 as-built surface and compared that to 2025 LiDAR. And what it shows you is areas in red is where you've had erosion happen. Areas in blue are where you've had deposition happen. And it allows our folks to go in and with the help of aerial imagery, go in and identify what's happening in these areas. And some of the things, I know it's hard to read, but what some of the things that you see, these processes with the erosion and deposition is you see bar formation in the channel. You see changes in the floodplain elevations, changes in the side channels, whether they're enlarging or filling. And like I mentioned before, you can see where emulsions happen. And the interesting thing about this geomorphic change detection analysis is it shows that if you look at just the Clark Fork River channel, about 27% of that channel area saw some kind of erosion or deposition over this monitoring period. But the interesting thing is if you look at the size of that channel, it hasn't changed. It's only 4% smaller on average than what it was designed to. So what that means is that, yeah, there's some movement and sediment is moving through the system, but overall we're functioning in what we call dynamic equilibrium. I mentioned we had the Tura study reach where we've done a lot of the same analysis. This is the reach where there was no restoration work done. And we ran the same analysis for the Tura reach. And again, similar processes noted here. There was an emulsion, there's side channel enlargement, there's bar formation, natural processes that we would expect on the Clark Fork River. This reach, 44% of the channel area saw some form of erosion or deposition. But like the restoration reach, it's functioning in dynamic equilibrium. The channel area itself only changed by 4%. So we're seeing kind of equal the erosion and deposition balancing out and sediment transport balancing out. These were major objectives of the project. Looking at some of the cross sections, here's a cross section of the valley. Areas in blue or green there show areas where we've had some aggradation. In this case, we see maybe a little bit of pool filling. Areas of scour on the floodplain where new side channels formed, or wetlands in the floodplain have formed. Changes in side channel depths, variability across the flood. The other analysis I wanted to focus on here was floodplain connectivity. This was probably one of the most important objectives of this project. So the analysis that we did for floodplain connectivity was to use our 2025 LiDAR and look at the elevations of the floodplain relative to the water surface in the channel, which at the time of the LiDAR was below what we would call bankland. So we were able to do some calibration of that and map out floodplain connectivity. So what you're looking at on this map of the Clark Fork here is anything in blue is 1 foot above the water level. Anything in green is 2 feet above the water level, and we have identified that as being pretty close to our design bankful elevation. And anything in yellow is about 3 feet. And so you can kind of get a sense of what floodplain connectivity looks like through the reach. And really the take home here, like we saw in those flood area photographs, is the very upstream end, floodplain connectivity is valley-wide, extensive. As you move downstream, the floodplain becomes confined within the terraces by design, and it starts to transition to more of that confined channel type at the confluence. One thing I did want to point out, the area circled in red, you know, of course, not everything performed exactly as designed, and we did have some areas that were damaged that we weren't able to go in and fix. And this one area here in the middle of the restoration reach is an area where we lost our grade control. We saw some channel incision and the floodplain became disconnected. And so we did see some localized channel adjustment in this area. It was about 3,500 linear feet. And the channel cut down about 2 to 3 feet. And that happened in response to those initial floods, 2010, 2011, 2012. Since then, that incision has been arrested. We haven't seen any additional down cutting since then. And the reach is a little steeper. It's got some rapids, steeper gradient to it. And certainly the banks look higher than other areas where we have good floodplain connection. But Amy will probably touch on this. Because of those large floods that did actually overtop the banks and connect those areas, we had an excellent vegetation recruitment response on those surfaces. And despite the channel incision, floodplain is meeting the objectives there. So we didn't feel the need to go in and do any heavy-handed maintenance in this area because the floodplain exhibited the conditions that met our objectives. The last thing I'll touch on here before I wrap up and turn it over to Amy is how did our structures perform? As I mentioned, to hold this channel in place in the short term, we had to have a number of different types of structures. A lot of the stream banks had bioengineering treatments, so that's clear fabrics and materials that also included, in some cases, some brush and willow cuttings. And for the most part, what we've seen with those bioengineering stream banks is that they're decomposing as expected. A lot of them, you can't even see the fabric anymore. But the willow establishment is pretty amazing. Large wood structures, so those were used on a lot of the meander bends to support pool development, deflect flow away from the banks, and all of those structures are intact and maintaining pools. And one of the questions when we originally designed those structures was, how long will they last? And they last at least 15 years. I think they might last. And they continue to recruit wood and provide excellent habitat. The last type of category of structure was our grade controls and engineered riffles. So these are the straight sections in the river. And like I pointed out in the floodplain connectivity analysis, we did have some mixed results. There were some places where our riffles and our grade control structures did not hold up. But I do want to say, as this project progressed, the use of different types of grade control structures over the course of this project, the adaptations that were made were highly effective. And by the time the last phase of this project was built, as the project approached the confluence, we weren't using these boulders placed in a row, and the boulders were more scattered. They were distributed. It's more of a matrix to make it look like the natural riffle. And those ended up being way more effective at holding grade and providing function than some of the initial structures that we used. And I think that's an important part of this project, is that when you work on something for a period of time, adaptive management has to play a role in how you approach the project. And I think Um, going back to my initial statement, how there wasn't really a manual or playbook to go by, we really had to rely on learning from as we went on this project. And so a lot of the takeaways are related to how this team adaptively managed the project. But just to recap here, kind of the key takeaways that I wanted to emphasize is that we've got reach scale stability, even following 2 major floods on the project area. Stream bank structures, these are the ones on the banks, successful at limiting erosion and establishing vegetation. Riffles and grade control structures, partially successful, but a lot of lessons learned. And these are things that we use on our projects today, based on what we learned from structure performance at Milltown. From a geomorphology perspective, the river's functioning in dynamic equilibrium. The sediment transport is balanced. What's coming in seems to be what's going out. We're not seeing massive aggradation or incision throughout the reach. Active fluvial processes, floodplain connection, large wood coming down the river and accumulating, building new debris jams, side channels. Lots of really good things happen. And Amy, I'm sure we'll talk about this. I'm setting you up.
I know.
Lobbing you a big softball. So she's going to talk about how these floods were a blessing in disguise. The beneficial impacts of the floods, as terrifying as they were to watch, they were probably one of the best things to happen. The other thing I'll point out here is that balancing stability and function. That was a huge challenge on that project. And even 15 years into it, people will ask, no, these banks are never going to move. What about those tow logs? They look like they're going to be there forever. However, there are signs of little chinks in the armor where the stream banks are starting to decompose, deform, and the river is taking over. It's just going to take time. And the last thing I wanted to point out is evidence of resiliency. We've had those 2 big floods, 2011, lots of damage, lots of maintenance required. Similar sized flood in 2018 after several years of vegetation growth and establishment. Totally different story. And I think that is a sign that what's happening out there right now is going to be resilient for years. Ability to self-maintain. I think that's it. You guys may remember some of these fun bumper stickers around town.
Hey, Matt, before you move on to the recording, I'm Gary Decker, one of the original designers in the project. When we came up with the original design, it went through a fairly intensive peer review process, academia and other people. One of the common themes of the review was that you can't make a single thread river in this setting where it's confluence of 2 major rivers. We did a lot of study to address that situation, but do you think this data kind of addresses that major comment?
No comment. Good question. Maybe are we saving questions for the end, Doug?
Yeah, we probably should.
Okay.
That'll be a lively debate.
All right.
Give
You had to bring it
me
up.
a little time to think.
What's the title of yours, Amy?
Something to do with Milltown.
Milltown Floodplain. I got, yeah, Milltown Floodplain. Think I'm sharing. And does your thing work? There you go.
All right, well, I'm Amy Sacry. I'm a restoration ecologist or biologist, depending on the day and my mood, I guess. Geum Environmental Consulting, and I was part of the design team with Gary and Matt and John and Sarah and Tom in 2005. So also did construction oversight, mostly of the stream banks and the revegetation at the site, and then been working with Doug and SWCA and other state people doing maintenance and monitoring for the last 15 years. So this is kind of a little bit of an OG reunion here and very cool. And also this was one of the first projects that Geum ever worked on. So I want to shout out to my partners there and also to Doug, keeping us involved for 15 years. So I'm going to be a little redundant with Matt, but I'll try to build on it more than repeat. So as Doug mentioned, the goal of restoration was to restore the Blackfoot and Clarkford rivers to naturally functioning, self-maintaining systems. And we had expectations for how that needed to be done in the short term versus the long term, as Matt talked about. So in the short term, we expected our structures and size material that these guys put in the channel and our elevations to kind of control where the channel was and the stability of the site. But long term, we always knew that we needed to establish diverse, highly functioning riparian floodplain vegetation communities at the site to provide the long-term stability, as Matt and even Gary both just talked about. So then how did we go about designing the floodplain to support those diverse riparian vegetation communities? Well, we started by looking at how a natural floodplain would function. So as Matt talked about, we always knew connectivity was one of the main criteria needed to have this project be successful. So connectivity between the channel and flood flows and the floodplain are what initiate natural vegetation community succession in these floodplains. And in our large alluvial river systems in Western Montana, the endpoint of that succession is very often a black cottonwood riparian forest. And that those forests are initiated by cottonwoods and willows, colonizing bare moist substrates that are often deposited by floods. And over time, in the absence of continued disturbance, those cottonwoods and willows. Isn't that nice? I saw you took a picture. ChatGPT made that for me on Friday. Anyhow, over time, then in the absence of disturbance, the cottonwoods and willows will grow and start to change the site conditions, increase moisture, increase shade, trap sediments, start building soil, and set the site up to support later successional vegetation, such as mature cottonwoods, conifers, red oaks, or dogwood. So this was basically then the template that we used to design the floodplain at the site. So Matt kind of showed this graphic already, but this was kind of the basis for our floodplain design. We took that kind of template of vegetation of the black cottonwood riparian forest establishment succession, and we tried to mimic the conditions that you'd find in a natural alluvial river and use that to determine how we were going to build the floodplain and what treatments we were going to use. So we basically took those pathways of succession and used them to apply to the site. So for purposes of design and also for purposes of monitoring, we refer to those as cover types. And that's kind of how we monitor the site. So I want to kind of explain what those mean a bit. So basically, and Matt kind of gave a broad overview of this, but how we designed the floodplain and the revegetation plan was to mimic those stages of succession. So we would have a cover type that mimicked kind of that alluvial sand gravel deposition. That's our colonizing. So that's what's where vegetation community succession would be initiated. So in those areas, all we would have is sand and gravel. So that would be our only treatment. As we got a little farther, we wanted to set the stage for black cottonwoods and willows to colonize the site. So we'd still leave it as bare alluvial substrates, but maybe we would plant willow cuttings or cottonwoods in these areas. As we got farther from the channel, we wanted to set the stage for young cottonwood stands to establish. So again, we kind of leave it bare substrates, but we might incorporate more organic matter or woody debris or even plant cottonwoods. And then as we got farther from the channel, where we would expect less disturbance, where Matt talked about these higher elevations and, you know, supporting later vegetation succession communities, that's where we would place deeper soils. We kind of mimic the conditions that you'd expect in a more mature floodplain and plant those areas and place woody debris in those areas. And then we also had cover types that just kind of mimicked the natural patterns and topography that would be formed by alluvial river moving across the floodplain. So side channels, we had a lot of wetlands we created, like Matt said, that kind of mimicked where maybe an old channel stroll used to be. So then the main thing then that the main revegetation treatment that we did at the site was to go out and build those different cover types. So same picture Matt showed of Gary's 2011 flood, but it shows kind of those macro scale and micro scale features that we built at the site to set the stage for those various stages of vegetation succession to occur. So having outer meanders higher than inside meanders so that floodwater would go onto the inside meanders and deposit the sediment and cottonwood seeds there. Having our side channels and our depression features. Those were some of the main things that was probably the main revegetation treatment that we did at the site, which people don't typically think of revegetation as being this sort of thing. They think of it as planting the plants and planting the willows, putting on fences. But really for this site, and a good thing about how Doug and this design team always approached it was that we knew we had to set the stage for natural processes to ultimately determine what's going to be at the site for it to be successful. So other treatments that we used, Matt talked about some of the stream bank treatments. You know, we collected and installed 100,000 willow cuttings. All of these treatments were intended to provide that short-term stability while the vegetation established for the long-term stability. We built the banks out of coir fabric, woody debris, sod mats, alluvium. Oh, it's kind of weird to look back at these early pictures, isn't it? There's coir. And we did quite a bit of planting at the site, but these weren't our main focus. But we did plant, you know, 30,000 shrubs, 20 different species, 70,000 wetland plants. And then we went and protected most of those plants, either with weed mats or individual browse protectors, most of which are inoxin, like we've talked about. So yeah, so that was, but we ultimately knew that no matter how much we designed it and how much we planned it, that what was ultimately going to establish at the site was going to be attributed to factors that we really didn't have much interest. And primarily that's going to be how many floods there are, how often those floods occur, how big those floods are, what those floods bring in with them, whether that's good seed or bad seed or more contamination from the upper part, what hydrology develops. So and how the soil develops over time are some of the main variables that we couldn't really control that ultimately ended up determining what was at the site. And as Matt said, of course, that variability and unpredictability happened the very first year. We had the floodplain built, the channel built, the plants had just gone in the fall. So there was nothing kind of holding that floodplain together. And so we got a lot of erosion and deposition and a change as a result of that. So this is similar to what Matt showed with the blue being areas of erosion and the green being areas of deposition. So a lot of sediment was reworked. A lot of wood was imported. A lot of the soil we placed at the site was just washed away. So a lot of changes happened. As Matt said, we did a lot of maintenance in relation to that flood. But what this flood also did was initiate that black cottonwood riparian and forest succession process. And the site very much would not be what it is today if that flood hadn't happened, when it happened, and hadn't been as big as it happened. Because it wasn't only the magnitude of that flood, but the duration of that flood that also influenced the current site conditions. That flood was out of bank, what, 2 months. That flood was out of banks, which is a huge flood. So basically, what we see at the site today is a direct response to that magnitude and duration of that. So basically, the entire site was bare flood deposits. Granted, we built a lot of those, but the whole site was nothing but just bare substrates. No vegetation had established. So we get this very big flood that stays very high for a very long time. And we have bare surfaces and bare substrates everywhere. So basically what that led to is getting colonization of willows and cottonwoods in areas that we probably wouldn't have gotten it if that flood hadn't been that big and that long duration. So, you know, the flows were high, you saw them spread out across there. So basically, you know, flows come up, the cottonwood seed is released, and that is timed so that the flows come down and those seeds deposit, and it stays wet enough for the roots to develop and elongate. And then you only get establishment of the cottonwoods and willows in certain areas that maintain that moisture. This flood, though, was so big that we got those cottonwoods and willows spread out to a much larger area than we typically would. It stayed out of bank so long that we had a very high moisture environment that whole summer. So willows and cottonwoods were able to germinate and grow in those areas. And then we had 3 very good wet years following the 2011 flood. So that kind of perfect storm of ecological conditions really set us up for having the extensive woody vegetation colonization that we see on the site today. We also just straight up lost 5,000 plants in that flood. The ground that we planted in literally disappeared with erosion. So that's one of the lessons that we've learned from Milltown. As Matt said, at the time, we were trying a lot of new things. This is one of the first sites where we did floodplain roughness and microtopography, and now it's kind of industry standard if there is such a thing in restoration. But that's a big thing we learned here, is that wherever we can, we should rely on this happening, the natural processes bringing in the plants and woody vegetation rather than us planting them. So we lost 5,000 plants, but we probably recruited 500,000 plants. And none of these plants require weed mats or browse control or watering to establish. They did just fine without us. So that was a big lesson that we learned, is to work with those natural processes and set the stage on this sort of thing. That flood also brought in weed species. And the 2 most significant ones at the site that flood brought in were reed canary grass and perennial peppermint. So where we have low elevation areas, flood activated areas, and the reed canary grass came in, it kind of won the battle pretty quickly against the. And so we have a lot of areas on the site, a lot of our wetlands in these flood activation areas that are predominantly reed canary grass. But I think of perennial pepperweed as kind of one of the success stories a little bit at Milltown, because Doug and the state had a weed control program at the site before we even started restoration, during restoration, and then I think you were only required to do it for 5 years, but you've been managing weeds for the last 15 years. So at the time we built this, there was no perennial pepperweed at the site. It was kind of a new invader 15 years ago, so it was on the county's radar. We've got some big infestations in the upper Clark Fork, but this flood came. Perennial pepperweed reproduces vegetatively, so just big chunks of sod came in with the flood and were just plopped down in the floodplain and started growing and establishing. You could literally follow the perennial pepperweed paths through the floodplain, through the flood, where the flood activated things. But we were immediately able to get on that and work with the county, and perennial pepperweed is pretty much eradicated at the site. It could very well come in and probably will at some point. But weed control has been a pretty significant part of the last 15 years of maintenance of the site. So then, like Matt talked about, because of that 2011 flood and the extensive recruitment of woody vegetation that we got because of that flood, when the 2018 flood came, the site was much more resilient, and we had vegetation established in areas that spread that water, slowed that water, allowed sediment to deposit rather than scour, and the site became much more resilient. So I know this is a bit of a psychedelic slide, a little bit, but it's an important slide because this is basically how we are monitoring the vegetation community establishment, the development of vegetation community and those successional stages at the site. So basically what this is those design cover types that I was talking about. So when we go out and monitor, we get high resolution drone imagery like Matt talked about and LiDAR, and we field verify things. And we basically map all the vegetation cover types within our construction limits. So the top is what we mapped in year 5, the middle is what we mapped in year 10, and then the bottom is just last year, year 15. So there's kind of 3 important trends to talk about here that are kind of the results of our year 15 monitoring and tell us where we're at with the site. The first one is we kind of have this flood activation zone, which is in the top one, kind of the orange polygons. And those are our colonizing depositional cover types. So that's where we got recruitment of cottonwood and willow seedlings in response to that 2011 flood. By year 10, most of those orange areas have turned purple. And that is our pole cottonwood cover type. So that means that in those areas where we got natural recruitment, where we built the floodplain specifically to support the process of natural recruitment of woody vegetation, those areas are growing and maturing exactly as you would expect them to be. And then by year 15, we're starting to get some blobs of dark purple. And those are areas where the cottonwoods have grown tall enough that they're now mapped as mature cottonwood. Well, we'll call them early mature cottonwoods, but they're 20, 30 feet high. So they're definitely above the pole stage. They're starting to exclude each other out and turn into more kind of open stands of cottonwoods in those areas. And interestingly, those areas where we have the mature cottonwood are the highest flood deposits from 2001. So again, if that flood hadn't been that big and been lasted that long, we wouldn't be getting these later successional stages showing up within 15 years. So another important trend to point out are the blue, the light blue and bright green polygons. So those are our wetland areas. Those are shrub wetland, the bright green, and emergent wetland, the blue. So in year 5, you can see that most of the wetlands were where we built them. The depressions in farther from the floodplain are wetlands that were borrow areas that we turned into wetlands. But what you can see over time is the expansion of those wetland areas within that flood activation zone. And so, you know, ultimately, we talk a lot about floodplains being kind of this shifting mosaic of vegetation types over time that are very much influenced and controlled by disturbance dynamics from floods. And so it's interesting to see that shift in just 15 years of a lot more, you know, the polygons in the top for our wetlands are kind of how we build them. After year 10, there's a lot more diversity of shapes and colors. And then by year 15, even more diversity of shapes and colors. So we're starting, so this is kind of a way to kind of look at the overall patterns of the site and how the vegetation communities are starting to shift and change over time. And seeing an expansion of wetland vegetation has been a very positive. The third main trend, though, is the light green areas. And those are areas that are dominated by herbaceous vegetation. And that wasn't even a cover type. That wasn't something that we wanted necessarily or designed. Those were supposed to be mature cottonwood conifer areas. I'll talk more about, I mean, obviously, I don't know why we thought they would be mature cottonwood conifer after 15 years if we didn't plant a single conifer in those areas. But those are the one area at the floodplain, within the floodplain that maybe aren't as rapidly meeting our goals and objectives as some of them. So just to zoom in a little bit, and this, I'm probably going to contradict Matt just a tiny bit here, but this is that middle reach where Matt had his red circle and explained how in 2011, the grade control at the top kind of washed through a little bit and we lost a little bit of our floodplain connectivity. And I actually like this as an example because it really shows that even losing a foot to half a foot of elevation in a floodplain can mean the complete difference between having a functioning great wetland or a dry herbaceous upland that's not providing maybe as much habitat. And so that's kind of what you see here. You know, this is year 5, so we've got, you know, the colonizing depositional young cottonwoods in these orange areas. And this is a meander that didn't get disconnected, whereas this one, this is where we did get a little downcut. And so you can see that we didn't get the colonization of willows and cottonwoods in that area as extensively as we did in areas that were fully connected. So then this just is kind of some ground pictures of year 5 in those areas, showing one of the wetlands that was flood activated, early colonization of reed canary grass in that wetland. And then the top is one of our connected floodplain areas that we built to support succession, early colonization of willows and cottonwoods. You can see the reworking of sediments. You can also see some of our active revegetation treatments, things we planted, trenches we planted, and that sort of thing. But by year 10, you can see that we are getting those cottonwoods growing and becoming more young cottonwood stands. But you can see that that disconnected area still isn't supporting woody vegetation, but it's a very small portion of the area because we built in enough low areas. Like Matt said, we still are meeting probably our overall goals for vegetation at the site. And then, whoops, what those look like on the ground, you know, we're getting more wetland development, shrubs are encroaching into the wetlands, and our cottonwoods and willows are starting to grow and mature. And then by year 15, we've gotten a lot more mature cottonwood vegetation. The disconnected area is still green and herbaceous, but vegetation is starting to mature and shrub wetlands are starting to expand and take over some of the mature wetlands. So that kind of gives you an idea of kind of those patterns that are happening at the site. So in addition to looking at kind of those shifts in floodplain cover types and what they mean for vegetation community development, we also for 15-year monitoring looked at total vegetation cover, woody vegetation cover, woody vegetation height, and then vegetation health and vigor. At year 5 and 10, we worked closely with the University of Montana, Karen Nelson and students, and we actually did a lot of on-the-ground monitoring. We collected hundreds of plots to get at species level data. And we decided, similar to what Matt talked about with the geomorphology and the intensive data collection in the early years, we decided, I mean, that data was very interesting. It gave us a percent cover of noxious weeds. It told us about species shifts in individual areas, but it really didn't give us that big picture of how the vegetation communities were developing and shifting and what was influencing those patterns on the site. So in 2015, we also kind of switched to kind of completely remote sensing using the LiDAR data that we collected last year, the high resolution drone imagery. For us, we did true color drone imagery, but we also collected the near infrared color band with our drone. That basically is the color band between visible red and near visible red. And the only reason that's important is because vegetation absorbs that much differently than true color. So it basically, it's used in agriculture quite a bit. So it basically allows us to take those values and see what vegetation at the site is growing more vigorously, is more robust, essentially is healthier. So in terms of understanding if we've met our goals and objectives of functioning vegetation communities and self-maintaining vegetation communities, that was actually a very useful tool that we included this year. So total vegetation cover at the site is 82%. This is woody vegetation canopy cover at the site. Again, you can see kind of that flood activation zone through the middle are the green colors. So that's where we have the most canopy cover. And outside of that, some of the wetlands we planted and the outer meanders we planted also have some decent woody vegetation cover. So total covers 34%, which is up from 25% at year 10. And so one of the key trends at the site then is that flood activation translates to the areas where we have the most woody vegetation cover at the site. But those areas are almost predominantly black cottonwood and sandalwood willow, as they should be. The other areas at the site that we have woody vegetation are outside meanders where we planted and around our floodplain features that we planted. Those areas have less woody vegetation cover, but much more diverse species composition than the flood activated areas. And this was another lesson that we kind of learned at the site that we apply now to restoration projects. You know, we planted 20 species of woody vegetation at the site. And we basically got our species list for planting by getting out the Hansen riparian wetland classification for Montana and looking up the black cottonwood, red odor dogwood, and ponderosa pine, red odor dogwood habitat types, and looking at what species were in the plots that they recorded for us. So that resulted in a lot of species. It resulted in species ranging from early cereal to late cereal. So of those 20 species we planted, about 15 are still at the site, but only about 7 or 8 of those are what I'd call common at the site. So basically the lesson learned was that don't plant later successional species at a site that has absolutely no late successional conditions at it at all. Note the soil was crap. It was high light, high, dry areas. So the species that we lost that didn't establish were the later successional stuff like mock walnut or serviceberry, raspberry. Interestingly though, red odor dogwood, which is a later successional species, is probably our most successful planted species outside of cottonwoods and willows. And then we have this one little patch of elderberry that just is happy as a clam and has been producing seed since year 1. So outside of where we have woody vegetation, the flood activated areas and the planting areas, most of the rest of the revegetation at the site was seeding. And we seeded a nice diverse mix of native grasses and ferns. And for the first 3 years, those came in phenomenal. And our early data shows that almost all the species established, but by year 5, almost all of those areas that we seeded, those higher elevation areas outside of the planting and the flood activation, had transitioned almost completely or to almost all red tar. And that wasn't super surprising. It was kind of disappointing, but the soil, let's call it soil, the material we used to build the floodplain at Milltown was basically just sediments from on site that weren't contaminated enough to get shipped to Opportunity. And that limit was 400 copper, is that right? So basically, if the reservoir sediments or sediments anywhere on site had greater than 400 parts per million copper, it got shipped away. If it didn't, then we used it as suitable growth medium on site. So it turns out there's a lot more things in that substrate than copper, zinc and arsenic, or I shouldn't say nothing, but other metals. And so red top is an introduced grass, but it's highly adaptable. It grows in acidic soils, it grows in wet soils, it's very metal tolerant. It grows in low nutrient environments. So basically just it outcompeted and won that battle, given the soils that we have at the site. And so that has been kind of one of the ongoing, I don't know if it's really an issue, but it's affected us achieving kind of what we wanted in some of these areas in terms of species diversity and habitat and kind of functional capability. So I picked this side to show instead of the other side, because this, so we're looking downstream where the dam was. This is where the bypass channel is. So I-90 is kind of on the right side of the photo. So this was the very last area built on site. So it had a large pile of reservoir sediments sitting there to be used as growth media. And it got filled in and we seeded it and nothing grew, and we seeded it again and nothing grew. And so we were kind of like, okay, there's kind of something going on here. So we collected a lot of soil samples, and that's when we kind of figured out that the residual metal levels out there are somewhat phytotoxic to at least herbaceous. The woody vegetation seems to be okay. The other issue we had with this is that these sediments have been sitting at the bottom of this reservoir for 100 years. So the nitrate levels in it were phytotoxic to anything growing. Of course, nitrogen is just going to, as it's just going to filter out of the soil over time. So things did start to grow on it. It is mostly red top, but in that process of trying to figure out how to deal with these areas, we did try several different soil treatments. Amendments with lime and compost and trying to remove the top layer of soil. And so The one treatment that kind of worked was that we ended up importing clean cover soil. And you can see exactly where we did that. It's kind of that yellow area. You can draw the perimeter around it. And so in those areas where we import soil and reseeded it, we still have a predominance of native grasses, mostly basin wildflower. So whether it becomes red top in those areas over time or not, that's just kind of a piece of story of vegetation and lessons learned, I suppose. So we also looked at vegetation height changes over time. And so this shows vegetation height for areas that support woody vegetation. Again, the take home is that in that flood activation zone through the middle is where we have the most woody vegetation cover and the tallest woody vegetation. Again, some of the higher flood deposits are where we have the tallest cottonwoods out there. So the purple are kind of the taller cottonwoods. And, that's kind of what that area looks like as of last year. And then again, we looked at overall vegetation health and vigor using the near infrared light band and that we converted to NDVI values. And so basically what this shows is if it's green, then it has the highest NDVI values and therefore is the most vigorous, robust vegetation at the site. And so this kind of tool showed us pretty clearly what is the factors that are most influencing our desirable vegetation. And that is going to be that flood activation zone is the greenest and brightest. Of course, there's some unvegetated areas as floodplain processes and deposition and erosion continue at the site. But then the other key variable for getting successful, robust vegetation that's providing the habitat that we want and meeting our goals is where we have lower elevation. So any area that is basically intercepting groundwater for most of the growing season is also supporting very robust vegetation. And those areas tie very closely to what Matt showed for connectivity at the site. So within that 3 feet above the water surface and below is where we really are supporting the most diverse vegetation on the site. So that's just what some of those areas look like on the ground, where we have connected floodplains. We're starting to get a lot of beaver activity, which is further enhancing the hydrology and vegetation at the site. And then in those areas farther from the channel that aren't necessarily getting water flowing through them and flood activation, we are getting very diverse shrub and emergent wetland vegetation. And those are the areas that have the highest species diversity at the site. So this is kind of a lot of numbers, but it kind of summarizes our year 15 floodplain monitoring in a nutshell, I guess. So Matt talked about how for geomorphology, they're looking at overall erosion and deposition, and if the channel is really enlarging or smalling, and they're seeing it kind of be balanced between reference areas and what's happening in the project site. For the floodplain, it's not as easy to just look at a reference area and say, oh, this site is bad because we only have 10% of the species, or this site is bad because we only have, 10% of the woody vegetation cover. Because those floodplains were subject to that wide range of variability and factors that I kind of explained earlier. They are wider or narrower valleys have a certain sequence of floods happen to them. So instead, how we've always looked at it is by taking kind of a bigger regional data set of how these floodplain cover types might occur at a site in the short term and the long term. So that's what this shows is our cover types and then a proportional abundance or distribution of those cover types in the short term, 5 to 15 years, and then in the longer term, and compares those to the percent of area occupied by those cover types that we measured for year 15 monitoring. So I just grouped these a little bit as, the 4 orange rows basically represent those different stages of black cottonwood forest succession. So you can see the depositional areas that we got a lot of in 2011. Now we have about 9% of each of those cover types, and how they compare to short-term and long-term, they're kind of right within those ranges. And this lines up with Matt's data pretty closely, what he sees for erosion, deposition, and geomorphic shifts at the site. And then the younger cottonwood stands and the older cottonwood stands. You know, right now it's mostly young cottonwood stand without a lot of mature cottonwood. But by year 25, that's probably going to be reversed. And most of the cottonwood stands are going to be mature and the younger ones are going to be a much lesser percentage. So that very much shows that our intent of designing a floodplain to work with natural processes to initiate and drive vegetation community succession is happening kind of how we want it to say. And then our other desirable vegetation communities, the wetland areas, you know, we've got 9–10% of the area being those functional wetland communities, which fit with our expected ranges in kind of natural floodplain. But then what stands out is that, again, that herbaceous cover type, which was never a design cover type, but a lot of the site is that herbaceous, predominantly red top vegetation. And those are areas that the design intent was for them to be cottonwoods and conifers. Again, I don't know how they would have ever been that without us planting any. You know, they would have initiated as seedlings and over time become mature. So those areas, you know, a lot of that looks like that, red top dominated. So not a lot of habitat compared to the wetlands and the flood deposition areas. But where these areas are adjacent to edges of the floodplain, all the conifers that you see in there are from conifer rain from the adjacent slopes. So it may just be a time frame thing for those areas to kind of colonize with conifers and become kind of a more diverse habitat on the site. So that's kind of the floodplain 15 years later in a nutshell. Most of it achieving our goals and objectives, with the flood activated areas and low elevation areas being pretty high quality habitat, and outside of that, I don't know what. Red top.
Nice. Good there.
So we are now going to move to Ryan. Let's,
For,
yeah, just a second. I'm going to introduce you, Ryan. I got to introduce the redevelopment portion here. Let's see. So one of the things that, you know, there's always been a big part of the Milltown project has been the remediation, restoration, and then and redevelopment. And you know, the 3 R's. And so unfortunately, remediation could not be here tonight because of some of my scheduling and some of their scheduling. They do have some news or some information they do want to pass on to you in the near future. Molly with EPA indicated that they're not quite ready to do that. But with my schedule, I wanted to get this done, so we moved ahead. And Ryan was available with Fish, Wildlife, and Parks to talk about the 3rd R, the redevelopment portion of it. So I'll let you take that off, Ryan.
thanks, Doug. I'm Ryan Schreiner with Fish, Wildlife, and Parks. Like Doug said, I'm the Upper Clark Fork Recreation Manager. Typically, when I introduce myself to people, they ask me if I'm the new Mike Astudia. No, there can be only one, the man Mitchell legend back there, but I'm doing my best to fill in for him. So I manage Milltown State Park, Beavertail Hill State Park, and all the fishing access sites and campgrounds going toward Anaconda, out past Phillipsburg and toward Helen, up to Blackfoot. But the meat and potatoes of what I do is Milltown. So I was going to talk a little bit today about public use, recent public use, how we manage public use, a little bit about the projects that we've had going on in 2025, and a little bit about moving forward here in 2026. So some of these slides I made for last year for BNSF, I'll get to BNSF in a little bit, but they wanted to work on the bridge on the Clark Fork starting July 15th. So I made some of these slides to look purposely chaotic. So if they're a little busy on the eye, that was on purpose and it worked because they were great to work with and they ended up kicking out their project in August, which allowed us to get through most of our fluid season. So, yeah, monthly averages. So it kind of follows the weather, as you can see. Our peak is mid-June through mid-August, depending on the year. Typically, July is our heaviest season for use. Which one goes forward?
The right. Oh, no. Sorry.
I'll figure this out. It'll be done now. It should work.
Yeah, so these are historical trends. This is 2022, 3, 4, and 5. Basically, you can see a slight drop off in 2025, and that was due to the impacts most likely from BNSF. We closed a little bit earlier. And also, as you recall, last year was really warm and dry. So flows way down. Became more difficult to float from Milltown into town just because of the times of waiting. And then, of course, we see public use dropping dramatically when the university goes back to classes. We get these numbers from trail counters and vehicle counters. So we have both vehicle counter at the entrance and trail counters on the trails. Every time those ping, they register. We collect them at the end of every month. And I turn those numbers into our statewide recreation planner. And they have an equation. I forget what the number is, but it's one vehicle times, I want to say 2.65 people averaging. Every vehicle's got 2.6 roughly. I think it might be 2.4. That's how we get the numbers. And we see 30,000 people using Milltown Confluence and Gateway in the month of July and August. So 60,000 people served in just 2 months. And then after and before that, the use is pretty much local folks, mostly Honor, Milltown, East Missoula folks walking dogs and stuff and different types of this. These are some of the new numbers that came out for all of our state parks here in the region. That's cleaned up. You can see this is Milltown. And then the only one that compares is San Diego State Park. So you would expect this year that the Milltown crescendo will kind of be more toward June because of the lack of water that we had in San Diego province. How do we manage all that use? It's a lot of use, and we don't have a ton of folks. But in 2025, including myself, we had 3 FWP staff members to help manage this. Now, 2 of us are pulled into the Upper Clark Fork as well, and so we have 1 full-time person who's fantastic to help us deal with this. And last year we had 4 Clark Fork Coalition River ambassadors to help as well. And that was a massive help. I put pictures of 3 of them here, which I stole from your outreach. But it's a massive, heavy lift that we wouldn't really be able to do without them. So we partner with Clark Fork Coalition. They've got this great program. I'm sure most of you are aware of it, but if you're not, they really help us do tons of public outreach. They're kind of the voice in the field that we can't be out there. They do survey work. They have inflation stations. I mean, really, it would look like a completely different thing if we didn't have the support from them. So what's great is we have at least 1 returning. So she's going to be able to take the torch in 2026 and have to train up the new folks. And I don't know if anybody else is coming back, but that's going to be massive. And then I as well have 2 returning staff. And we've got an additional staff member this year. So we've got funding for 1 more. And I was lucky enough to hire one of the Smith River Rangers to come and support us. So another high volume area. So it's just going to be hopefully a lot of great support in 2026. So this is obviously a map that everybody is familiar with. I just had, this was actually for BNSF, but just historical conjunction. Juniper Road. We actually have our river ambassadors and staff sort of base out here, helping people park, mitigating issues, giving out information, and then directing people to Juniper Road if we have, which we do pretty much every Thursday, Friday, Saturday, and Sunday. Last year, we closed because there was a BNSF project to work on the bridge piers right here and right here. And so, so this is what this ended up looking. These bridge piers, the one on the road and the one adjacent to the river, were sort of eroding, and they needed to come in and do some work. So what they ended up doing was having some heavy equipment come in on the bridge and drop all of these depot blocks onto this island and then replace them with the heavy equipment. So going back, so how we manage this, we worked with the river ambassadors to get the messaging out, and then we had their support, my staff and my counterparts up the Blackfoot stage at the confluence in the water, literally stopping anybody coming through to let them know what was happening. We had people further up at the way station letting them know, and the river ambassadors had the messaging at that point for 3 weeks. Because what NSF ended up doing was blocking off this channel right here, which is where all the water wants to go. They assured us it wasn't going to be a problem. We didn't believe them necessarily, but they were correct. They ended up doing this, and we kind of expected some weird hydraulic or eddy here, which is what we were really worried about for public safety. And at the end of the day, all it did was keep the water above there, form kind of a fun, splashy rapid down the center in sort of a slower, easier route of this one. So we posted this map, station those people look. So that construction is finished, but they destroyed the road going. I mean, purposely destroyed the road going in, and we weren't able to fix that before winter. A lot of people are still going to Milltown, so maybe you walk back there and seen it. You can drive on it, but we didn't know that we were going to have the winter we had. And we kind of figured with all the snow and freestyle people that kind of end up being bigger. So we kept it closed over the winter. Surprisingly, not a single complaint. Anytime I'm out there, the people that are using it are thrilled because there's no cars coming in and out there. There's a huge playground themselves. They come in. We are scheduled. I spoke with a gentleman from BNSF yesterday, and they are subcontracting that out to Knife River, who went out or is going out this week to look at it. So they should be paving the section that's destroyed, and hopefully it should be open by May 1st. That's the goal, unless something happens. But so for 2026, we're going to see an impact on the lower Blackfoot. BNSF has to come in and work on their bridge, which is here. In order to do that, they've described this to me, so it's hard for me to picture, but essentially they're going to have to make a bridge under the bridge or have some kind of scaffolding coming down from the bridge. That is going to create potentially a barrier, and at the very least be dangerous for if anything potentially falls off while they're working. So we're going to have to close this section. Of course, the commission's going to have to approve that, which they haven't yet. But that's set for the June meeting. But their permit is from July 15th and it runs to October 31st. And they have informed me that they think they're going to get every second of that permit. So we can assume that we're going to have impacts starting July 15th and close the section with commission approval. What they're going to do is come out of Town Pump, punch a road, close our trail, Gateway Trail, and then do their work. And then as they come out, fix their Gateway Trail. So a secondary impact from that will be the connectivity between Gateway and the confluence will be disrupted. Now they will have it fenced off, so you'll be able to walk up to the fence, take a gander at what they're doing if you want, and walk back. So there'll be a barrier there, but it won't be. My supervisor, some of you probably know Ben Dickinson, he's working on getting biannual closure. I forget the exact name, but essentially, because of this work, let me go back. We want MDT, and MDT wants to take out their bridge piers. In order to do that, this BNSF work has to take place. So I'm getting happy. In order to do that, BNSF has to do their work first, because when those bridge piers went in, it was a reservoir. And so their fear is when MDT takes out their piers, it'll change the hydraulics there. And so basically they want to make piers that are designed for moving water. That's the whole reason this is all taking place in the state. There should be no disruption. I mean, we're going to close the river from Way Station to the I-90 bridge. That's going to be the closure, which means you'll still be able to access launching at the conference. And there should be no disruption whatsoever to that.
Ryan, when's the MBT project?
The MDT project is scheduled for next year.
That's what they always say.
They have a little website that you can go to and it kind of lays out what their plan is and you can call somebody. I got a hold of somebody over there in December and it is their intention to do it next year, provided it be in the 7 piers are out. That's why we want to get the biannual rule so we can pivot a little bit swifter than having to get commission approval. Because one thing that took place, I should say, I do want to say the BNSF folks have been awesome to work with. But one thing that took place last year with their project, they wanted to start, but there was an emergent issue somewhere down the line. I'm not sure where, but some of the equipment that they needed to finish their project was taken to something else that was more critical. So there's always that can take place. We don't anticipate that, but these timelines, I just want to say, unless, if something happens to it, even major, God forbid there's an accident. With best intentions, that should be what takes place. I just kind of threw this one on here. It sort of speaks to the adaptive management stuff. I'm the newest kid on the block, probably of everybody in this room with Milltown. So I haven't been involved with all the restoration stuff. All I'm seeing is the back end successes of the restoration stuff. So this picture I took, same day I took this. This is us redoing the Milltown overlook. As many of you probably know, we had to pull that away from the edge because there's a fissure there. I went out to just chat with the contractors, check on their work, see if they needed anything. And this picture was taken the same day within 30 minutes of this picture, which is the pond just below. So I just threw that on there because it's pretty close. Okay. And just highlighting, we don't get a whole lot done. I have to repeat it out on partners. So it's been a huge success. So in 2025, we did just that. We took the Milltown overlook and relocated it from its original footprint to bring it back. And that's because there is a fissure there right on the edge that's growing. You can see it sort of growing. And they hired consultants, it wasn't safe. So this is kind of a cool shot. This machine was masticating the original asphalt and then repurposing it as the subgrade for the new path, which I had never seen before. Well, anyway, these are some of the future stuff that we're working on. We have a plan to redo a large portion of the paved trail. I've been out there lately, you've probably seen that there's a lot of things pushing up into it. And so we've got design and construction, Helen, working with myself and our maintenance folks. We went out there last week and the week before last to look at it, to talk about what we need to do to fix that. So we'll be doing some trail restoration in kind of this area. And we're hoping to hire some MCC crews, Montana Conservation Corps crews, to work on some of the sections and get some of the trails repaired and fixed. We're going to do some more signage, both at the overlook and at some of the other areas like Gateway and the confluence area. So, and then yeah, just some impacts going to take place because of the hearing stuff. And then, of course, there is the Blackfoot Crossings LLC development property, which they have some small traffic impacts on the gateway. But as you all probably know, they're back to the drawing board on what it is they're doing there. So I spoke to the developer yesterday and basically said to expect intermittent heavy equipment in there, sort of to the extent that it already has been. So that's pretty much what I know about that. And that's all. Looking forward to the season and thankful for everybody's support, especially our coalition. Any questions?
Well, nice. Before we go, or before we move to questions, first of all, I'd like to give the 3% as a. Thank you. I'll stand up to practice. Do people need to stand up and stretch for a little bit, or do we want to just go in and start with some questions? Just,
You somehow use the microphone for the questions.
Yep.
Or can they repeat the questions? So
yeah, we can make sure we. So, but people need to take a break. Are you coming up with our speakers? So does anybody have any questions here? In the meeting room first, we'll start in the meeting.
I just have an observation.
Your name.
My name is Mary Erickson. We live on the upper section of the more remote development area on the river. And met with Ryan out there. Watched some trout rising to a hatch. It was just amazing, right at the mouth of our side channel where it meets the river. And I just want to tell you that the bar logs are still in great shape and they're throwing up all kinds of goals. And the tow logs are definitely doing their job. But just downstream from our fence line, the beaver have decided that your tow logs are an awesome place to build a lodge. And so they built a rather large lodge with the tow logs as their base of operations. They also are kind of clear cutting the bank down there, and I don't know if that's a concern or not. And in that side channel that goes over by the sheriff's posse is a huge beaver dam. So yes, we have beaver activity, and we've got 2 dams up to our place and 3 or 4 lodges. That's
Nice.
an observation. And my other observation is that if you guys aren't very, very proud of this project, you should be.
Yeah, this is Doug speaking. I think we all are. It's actually a fun place to come back to and take.
So I'm just Gary Matson, and I really is satisfying to see those aerial photos used and play a role in telling the history of the site. However, I did not take those pictures. So Judy does what all wives do and told her husband where to go. And I had to find a flying airplane and she took the picture.
So we just need to put that aside.
Yeah.
So, but my question is that the reason I think this site was designated Superfund is because of arsenic in the water in Milltown. And so if there's 4 million cubic yards remaining, is the arsenic going to continue to contaminate groundwater, or is it not because it's out of the bottom of the reservoir like it was before? Does that make sense? I mean, if it's dry and it won't contaminate groundwater, or is the groundwater have less arsenic than it did in 1982?
Do you want me to point it to you?
Sure, yeah, I can speak to that. I'm Brianna Pabst. I'm the new DEQ person on the site, so I've only been on the site for about 2.5 years, so I'm still kind of getting my bearings. So it's really great to see all the work that's gone into this. But for the remediation portion, we are still monitoring the groundwater, and there, like you said, there was a really drastic decline after the removals. The groundwater has gone very close to the cleanup levels, but it's kind of flatlined at this point. So we are going to be doing some additional sampling in the area to kind of get an idea of what the groundwater is looking like beyond the site and kind of look at the next steps. But it definitely has gone down very, very close to our cleanup levels, but it's kind of flatlining now. So we're going to need to look at it again.
Yeah, you know, who Lynn Bell is? Well, he was the guy that volunteer, I guess, a geologist. Anyway, he mapped out the arsenic plume. And so I guess the reason is that the plume was because the solution to pollution is dilution. And as it went downstream, it got left. I guess, I don't know that, it just seemed like it would be interesting to know if that was changing.
Yeah, it definitely is going down for sure. Yeah.
From my observations, this is Doug Martin speaking, from my observations and knowing what it was previously to where it is now, there are areas where there's that contamination that has been left in place, for instance, under the interstate. That, you know, that the interstate couldn't be moved to get to that. That's where the areas of elevated concentrations are. There's another area over by Tunnel Pond, that's another area where they had left waste in place. There's a well over there that's right on the edge of the, you know, the contaminant,
Thank you.
Any other questions in the room? Any questions online?
Watson just had a nice comment, and she had to teach cool water food.
Well, if there are no other questions, I know, we'll be hanging around here for a bit, cleaning up and doing other things, but, you know, once again, I'd like to thank everybody. And I can speak for the restoration team, that, you know, this was this was a great project. We all enjoyed, working at it. We all enjoy coming back and looking at it. But we also know that we didn't do it. You know, everybody was involved. The public here, all you folks showing up, for years of public meetings and giving us, some input, you know, working with our fellow partners, the NGOs, the other agencies. It was a great project to work on. And it's a very big success. And I think we all look at that myself. I think we all need to give ourselves a round of applause. Thank you. Yeah, thank you for coming. Hopefully, well, we are turning the site, that resource damage program is turning the site over more thoroughly to Fish, Wildlife and Parks. They're gonna take over the weed control, and implement that. Since we haven't done a lot of maintenance in the last few years, you know, we're looking at, you know, letting the natural processes take over and do what Mother Nature is supposed to do. Yeah, thank you.
Thanks, Roger.
Thank you. Recording. Didn't mean to throw you in there. Didn't mean to throw you in the spot.
Okay, yeah.
You're like,
Congratulations. Start.
yeah.